A jet engine is a type of reaction engine that converts fuel energy into thrust, which pushes the aircraft forward. Machine learning, ML, can be used to predict an upcoming damage of jet engine, hence preventing any major damage or accident, and preventive maintenance activities can be carried out as a corrective measure. ML models can be trained on sensor data of a degrading engine to predict health of an existing engine. The main goal is to predict the remaining useful life, RUL, of each engine. RUL is the equivalent of number of flights remained for the engine after the last data point in the test dataset. The CMAPS software was used to simulate engine degradation at NASA Ames facility. Various sensors are placed at different locations and data of 100 engines are recorded. Below are the list of sensors and simplified layout of engine components and working mechanism. Let's start building machine learning model with exploratory data analysis. Importing basic libraries and data. Creating a new data frame separately for maximum cycles of each engine. Understanding the data. Adding RUL column to main data frame and appending RUL values for each engine and respective cycle. Feature engineering and visualizing the data. Creating a bar graph to visualize number of cycles for each jet engine. Creating a distribution plot of number of cycles after which jet engine fails. Creating subplots to find data distribution of each sensor input. Creating a correlation heat map to determine important features with respect to RUL. Dropping unimportant columns. Plotting sensor data with respect to RUL. We see that physical core speed sensor and corrected core speed sensor behaves differently for each engine. Also, both of them have correlation coefficient lower than 0.5 with respect to RUL. Hence, we drop both the sensor columns. Standardizing the data. Adding output column label to set less than 30 RUL to 1 and rest to 0 and hence making a binary classification dataset. Generating pair plot to visualize safe and unsafe data points. Building model with logistic regression, support vector classifier, random forest classifier and decision tree classifier. Finding best parameters and training each model with these parameters. Calculating results on test data. We find best recall score of 81% with logarithmic regression. Exporting logarithmic regression model for deployment. Using Streamlit to build an application for predicting safety of jet engine. Setting input boxes for entry of sensor values. Predicting safety with sensor values of damaged engine. Predicting safety with sensor values of healthy engine.